Hello friends. Welcome to T Academy. In this video, I am going to discuss the previous Telangana State Tsspdcl Assistant Engineer Electrical Paper 2015 here. Okay, so as you know that I already discussed the 2018 paper and a part wise. Now in this video, I am going to discuss the total 80 questions. Okay, that is the technical questions asked in this examination paper. I am going to discuss here. So these are the technical question paper here. 80 questions are there. So let's start the first question here. If you are new to my YouTube channel, please subscribe and share this video with your friends. And in my YouTube channel, I have discussed the previous AE papers and SSC papers. Okay, so these are all are helpful for your examination preparation. Okay, and yesterday also I uploaded the TNPDCL AE notification. Okay, so please go to that video, and if you are eligible, then start preparing. And one more thing is, some of you are asking without watching the video, you are giving comments there. That's whether diploma is eligible or not, for example, right? In that video, when the qualification is there, I mean, I stressed the point that only BTech are eligible. Then again, you are commenting and asking, sir, is that EC students are eligible or a diploma students are eligible means, if that means you are not properly watching the video. Okay, if you watch the video, then I will stress that points there itself. Okay, so without wasting your time, we'll start the video here. So the first question is, in a single phase RL series circuit, if the current lags the supply voltage by an angle phi, then the voltage across the inductor dash the supply voltage by an angle of dash here. The simple thing is here, in the given question is that, what is that? Is a series RL circuit. So series RL circuit like this. Here we have like this. Okay. Now, if you draw a phasor diagram of this one here, so let me take here. So this is the VR, voltage across the inductor, and this will be VL, voltage across. Sorry, VR is nothing but voltage across a resistor. This is a VR, and this will be VL here. Now, what is supply voltage? Supply voltage is nothing but Vs, which is a having an angle of phi here like this. Okay, phi. Now, okay, see here, the inductor voltage leads the supply voltage. So first option it is leads here. And what about this angle here? So let's assume this entire angle will be some 90 degrees here. And this part will be some, let's say, x here between these 2 points. Okay. Now 5 plus x is equal to 90. What is x value? X is equal to 90 minus 5. So the VL leads the VS by angle of 90 minus 5 here. So answer will be C here. It leads, and here answer will be 90 minus 5 will be the answer for this question here. Okay. Let's move to the next question here. Uh, 4 parallel resistors connected in parallel with the 5 resistors. Understand the question here. 4 parallel resistors. So 4 parallel resistors means 1 here like this. Here we have 2, and here we have 3, and here we have 4. So these are the 4 parallel resistors. Is connected in parallel. So is connected in parallel with what? Parallel with 5 series resistors. That means here we have series resistance 5 like this. Okay, so here we have 5R. This will be R. Okay, connected to a supply voltage. So here we have supply voltage of 210 volts here. Okay, and current flowing here is 5 amperes. Okay, what we need to find here, it is, if the R is the resistance of the each resistor and current 5 amperes, then the value of this R is. So understand these equal values. So 5R is there. So I will redraw it. Here we have a 5R resistor, which is in parallel with the 4 resistors, means I can redraw it equivalent as R by 4. Now, okay, these two are equal, and there is a supply of how much? 210 volts, and the current will be what? 5 amperes here. Now, R equivalent will be, what is R equivalent? R equivalent will be 5R is in parallel with R by 4. Okay. Now, this can be, R equivalent will be what? It is 210 by 5. Okay. So, these two are parallel means what we can write? R1 into R2 by 4. R1 R2 by R1 plus R2, which is equal to 210 by 5, and solve this equation. You'll get the answer as a 882 divided by 5 ohms. So answer will be D. So 882 divided by 5 is the answer for this question here. Okay. Good. Okay, next question, sir. See here. An inductor of Q factor is a 10 is connected in series with a capacitor having a Q factor of 100. The overall Q factor of this circuit is. So what is the value QL? QL is nothing but 10. QC is nothing but 100. Now overall factor. So Q naught is equal to QL into QC divided by QL plus QC here. So from this 10 into 100 divided by 110. So you'll get the answer as, so answer will be what? It is 100 by 11 here. So this will be 10 gets cancelled here. 100 by 11 is the answer. So answer A is the right answer. Next one. Okay, right. So this question is from the control systems. Find the Laplace transformation or Laplace transform of the function shown in the figure, following figure, right? So here there is a figure, if you observe here is a magnitude of 4 volts and it's starting a ramp signal here. It's a 1. Okay. So its Laplace transformation will be, so magnitude A divided by S square into e power minus A into t, or in terms of, if you write in terms of uh, Laplace transformation, u minus A into S here. Okay, so what is the A here? A is nothing but 1. This capital A will be 4 here. That means 4 divided by S square into e power minus 1 into S. So this will be answer. Okay, so answer will be A here. Next one. A three-phase 400 volts balanced star connected load takes a current of 2.5 amperes and the power factor is measured by 2 wattmeter method. If the lower value of the two positive readings, is 707 watts, what will be the power factor? So we know that the formula for the power factor is, wattmeter readings, W1 is equal to some V into I into cos 30 plus, I'll write here plus or minus 5 here. Okay, I will neglect this part. I will not consider it as, okay. So let it be W here. Now lower reading means here what will be the value? So plus indicates lower value, minus indicates higher value. So from this will lower reading they given, the lower value they given. So lower value you have to consider. That means wattage is 707 is equal to, it is a 2.5 amperes into 400 volts into cos 30 plus 5. So if you simplify this, you'll get the, it as root 2 is equal to cos 30 plus 5. Again simplify this, you'll get as a 5 value as a 15. Okay, 15 degrees. Now power factor. So power factor is nothing but cos 5. So what is the cos? Cos 15 degrees unit, right? So among the options here, so this will be the right option. D is the right option. Why? Because so power factor is what you can get as a cos pi means 180 divided by 12. So you're getting it as same, both are same only. So cos pi by 12 we can write. So cos pi by 12. So answer will be D here. Okay. Next question. Regarding resonance of a two-branch parallel circuit having RL combination in one branch and C is in the branch. Okay, C is in another branch. Okay, which of the following statements are false? So which are statements are false here, right? So here we have a resonance circuit condition in which we have one branch consisting of resistance and inductors, another branch is consisting of capacitor like this. So resistor, inductor, capacitor, right? And this circuit is said to be resonance condition. During the resonance condition of a parallel combination like this, there will be impedance is a maximum and current is minimum. So impedance is a maximum is a correct statement. Okay, and the two branches are exactly 180 degrees with each other. So that's the right option. And the resonance frequency Fr is equal to 1 by 2 pi square root of 1 by Lc minus R square by L square here. So let me correct here. Okay, right. So D is a resonant frequency. Fr is equal to 1 by 2 pi into square root of 1 by LC minus R square by L square. So two branches are not exactly with exactly 180 degrees with each other. So this is a wrong statement and this is a wrong statement. So answer is B and C are the wrong statements are there, right? So please make a correction that the impedance is a maximum and current is minimum. Okay. And resonance frequency Fr is equal to 1 by 2 pi square root of 1 by LC minus R square by L square. So these are the two correct statements and these two are the wrong statements here. Okay, please make a correction. Right. Next question here. A single phase circuit with a supply voltage V consists of resistance R and reactance X in series. Okay. The locus of the current is a circle. Locus of the current is a circle with a radius of dash when R is varied. So it is V by 2x here. So answer is a B for this question here. Next one. The RMS voltage of 35 volts is applied across single phase RC series circuit. If the RMS voltage across the capacitor is 28 volts, then the angle between the current and the supply voltage is. So there is a RMS voltage applied of 35 volts across a series RC circuit here like this RC circuit is a, and how much voltage we are applying? Yes, it is 35 volts here. And the resistor voltage across the resistor is VR and the voltage across capacitor is VC. We know that how to find out the VR and VC values. So VC values are given it as a 28 volts and we have to find the VR. So we know that 35 square is equal to VR square plus VC square. So VC value is 28, you know. Substitute the values here and you will get the value of VR is 21 volts here. Now we need to find the value of angle here. Okay. So cot theta is equal to, so it is VR by VC. It's nothing but 21 by 28, that implies 0.75. Now theta value, angle between them is cot inversion of 0.75. So answer will be D here. Okay. Next one. What is the voltage VAB across the current source in the following circuit figure here? So to find out this circuit here, first check this current here. So total current is 3 amperes are here, and here it is going to divide to two branches, parallel branches here. Apply current division rule here and find the values of current here. Let me take here, this will be I2, I'll take it as a I8. So first I will find the I2 by using the current division rule. So I2 is equal to the total current 3 into opposite resistance divided by total resistance. How much here it is? 16 means 1.6 here. Okay, current will be 1.6. And what about the V2 here? For example, here it is V2. Okay, so V2 will be, so I2 into 2. So it is nothing but 1.6 into 3 means 3.2. 3.2 volts. Apply KVL here in this loop. Okay, in this loop, if you apply KVL, so let's minus VAB plus 3 into 2. Okay, so 3 into 2 plus here the current will be I2. Okay, so let's make correct here. It's not a 1.6 here. So 2.4. Okay, so it is here. Here we have it as a 4.8. Okay, so voltage will be 4.8 is equal to 0. So from this VAB is equal to what we get, it is a 6, it's at 10.8. So among the options the matching answer will be 54 by 5 here. So 10.8 volts here answer. Okay, 54 by 5 volts, both are same. Next one. Choose the instantaneous power of a pure capacitive single phase AC circuit if Vm and Im and F are the peak voltage, peak current and frequency of sinusoidal supply. Okay, so when there is instantaneous power, so P is equal to Vm Im into, so sine omega t into cos omega t, like this is a formula. Okay, now if you simplify this one, so Vm Im by 2 into, okay, sine 2 omega t. So omega is nothing but 2 pi f. We substitute here Vm Im by 2 into sine 4 pi f into t. So this will be the value here. So we can write it as a 0.5 into Vm Im into sin 4 pi ft. But even in the given options, there are two options are correct. That is, first one is the A option and the C option. Sir, which one is to choose? So both are correct only. If the power is delivered by the capacitor, we can consider as a minus 0.5 Vm. It is power absorbed means 0.5 Vm here. Okay, so both are the correct options here. Next one. In a second order type 1 system for continuous oscillations, the time response is proportional to. So time response is proportional to 1 minus cos 2 pi fn into t. So how will you get this, sir? So what is the response of this second order type 1 system is C of t is equal to 1 minus e power zeta omega nt divided by square root of 1 minus zeta square into sine omega dt plus theta here. Okay, substitute the zeta value 0. Why? Because for continuous oscillations, undamped oscillations, zeta value 0. Substitute here. And what about the theta is nothing but cos inversion of zeta. So once you substitute this, what we'll get is e power 0 means 1, e power 0 divided by 1 into sine omega d. Omega d is nothing but omega n to square root of 1 minus zeta square. So omega d is nothing but omega n become here, omega n into t, plus theta is nothing but cos inverse of 0 means it is 90. So simply 1 minus e power 0 means 1. It is a cos omega n into t. Omega n, you know, there is a 2 pi fn. So answer will be B here. Okay. Next one. A differentiator is not usually used in a control system because. So it is not used in a control system because it will having a higher speed and a higher bandwidth. At the same time, it will increase the input noise here. So answer will be input noise here. Now, next question. Find the damped frequency of oscillations of the following system here. So here the system is given here. So here 4 radians per second answer. Okay, 4 radians per. Now here what we need to find is, let us consider this one as a g of s and this one will be h of s. Closed transfer function will be g of s divided by 1 plus g of s into h of s. Substitute in that form here. And g of s value will be what? So I will write it, g of s is nothing but 20 into 5. 100 divided by s plus 1 into s plus 5. Okay, and h of s is 0.2. Substitute this value in this equation and you will get the characteristic equation. Okay, so characteristic equation will get it, that is s square plus, I'll write it down here, s square plus 6s plus 6s plus 25 is equal to 0. So compare the standard equation, s square plus 2 zeta omega n plus omega n square. Then from this we'll get it as omega n is equal to 5 and zeta value will be 0.6. Okay, substitute these values, will get the answer here, right? No need of worrying about it. And after that, what we need to find is wd. So wd is nothing but wn into square root of 1 minus zeta square, the same formula which I have written here. Substitute the values here. Omega n is nothing but what? Omega d is equal to omega n is nothing but 5 square root of 1 minus 0.6 whole square. So if we simplify this, we get the answer as 4 radians per second. So answer is C. Next one. In a series RLC circuit has inductance of 2 millihenry and resistance of 1 kilo ohm and capacitance 5 microfarads. Determine the type of damping if the C is increased 1000 times its previous value. Okay, so zeta is nothing but R by 2 into square root of C by L. Now R value is what? R value is nothing but 1 kilo ohm divided by 2 into square root of C value. So now C value is decreased means, so it is in 5 microfarads. So 5 into 10 power minus 6. It is decreased by what? 1000 times means 10 power minus 3 divided by, and L value. So 2 into 10 power minus 3. So simplify this one, you will get answer as 0.8 here. So 0.8 means zeta value is what? Less than 1. So it is a underdamped condition. If zeta value is 0, then undamped condition. Zeta is greater than 1, overdamped condition. Zeta is equal to 1 means it is critically damping condition. Next one. The simple question. The third order polynomial p of s is equal to a1 is q plus a2 s square plus a3 s plus a0 is stable if. So if the product of A2 and A3 should be greater than A1 and A0. So you can use the RS table for getting this answer here. So simply I'm writing, so A2, A3 should be greater than that of A1, A0. Next one. The state space model x dash of t is equal to a of t into x dash of t plus b of t into u of t, y of t is equal to c of t into x of t plus d of t into u of t represents dash system. So state space model is a continuous system. Okay, so continuous system, it's a continuous time variant system. So answer is it is going to be, answer is C. So it's a continuous time variant system here. Next one. For measurement of radio frequency AC signals, dash type meter is used. So for the measurement of the radio frequency signals, okay, thermocouple is used here. So thermocouples are very accurate for higher at higher frequencies. Okay, so they're very accurate at higher frequencies. So that thermocouple is the best preferred for measurement of radio frequency AC signals. Next one. Creeping error. So creep error in a single phase energy meter when dash is energized, and it is mainly because of dash for friction. So when the creeping error occurs, especially when the pressure coil is energized, and it is going to be the compensation is overcompensation, right? So answer is the pressure coil is energized, okay, and compensation is overcompensation. Because of that reason, the creeping error, that means that the disk will rotate even the current is zero. That means that it's not the current coil is not energized, but the pressure coil is energized, so that and due to overcompensation the disk starts rotating. So even though you are not using the electricity, you will get a bill. Okay, so this especially happens in energy meters, right? Next one. The Maxwell inductance capacitance bridge is a has a resistance is in dash with standard capacitor and a dash in Hayes bridge resistance. Okay, so when you have seen this bridge, okay, that Maxwell inductance capacitance bridge, in that bridge, okay, there is a, right, I'll draw the circuit here. So I'll draw the circuit for you here. So we have a galvanometer here, and here we have some resistance and inductance R L here, and here we have resistance R2, and here we have R3. So these three part of both are same. In case of inductance capacitance bridge, here we have capacitor is in parallel with resistor like this. Okay, so capacitor, a resistor is in parallel with standard capacitor. In case of Hayes bridge, this everything network will be same. This part, entire part will be same, and here this part there is a resistor and capacitor, both are in series. So answer will be D here. Okay. So next question. The resistance pattern on the screen of a CRO in an oscilloscope with a major axis in quadrant 2 and quadrant 4, the phase, okay, the phase difference between the two signals are, okay, when there is in quadrant 2 and quadrant 4 like this, there is a that two, it is a ellipse. Okay, so these are the quadrant 2 and 3, and the phase difference between the two signals will be either 210 degrees or either it may be 150 degrees. So answer will be B here. Okay, right. In a CRO, during the retrace time, the electron beam travel dash from of the screen. So it is horizontally from right to left. Answer is C. Next one. The Poisson ratio of a resistance wire gauge is 1.8. Then neglecting the piezo resistive effects, its gauge factor. So gauge factor is nothing but 1 plus 2 into mu. Okay, so 1 plus 2 into 1.8. So it's nothing but 3.6 plus 1. It's a 4.6. When the diameter and the thickness of diaphragm of a pressure sensing unit are doubled, then its natural frequency will be. So natural frequency will be Hall here. Next one. Choose the incorrect choice. Choose the incorrect choice from the following. As a load torque increases, speed of the motor decreases. So as the load torque increases, the speed of the motor DC series motor decreases. As the load torque increases, speed of the DC shunt motor decreases. As the load torque increases, the speed of the DC cumulative compound motor decreases. But the DC differential as the load torque increases, the speed of the motor is increases. So this is the correct, this is the incorrect statement here. So differential, it's not coupled, differential compound, okay. Differential compound motor, right? Next one. Right, next question. In a torque slip characteristics of a three-phase squirrel cage induction motor, the maximum torque is. We are not getting a maximum torque is, it is the variable is nothing but slip here. So when dt by ds is 0, we will get the maximum torque here. Next one. In a three-phase alternator, if there is only magnetizing armature reaction, the type of load is. The type of load is a capacitive load. Next one. The Portier triangle is always dash triangle in the measurement of a voltage or regulation of a three-phase alternator using dash method. It is a right angle triangle. So right angle triangle and using a ZPF method. So answer is C. Next one. The eddy current losses in a DC generator is a 400 watts at a 40 Hz frequency of reversal and a flux and constant flux density. When the supply is increased to 50 Hz, the eddy current loss will be. So eddy current losses, we know the formula. Eddy current is proportional to F square. So W2 is equal to W1 into F2 divided by F1 whole square. So what is the W1? It's nothing but 400 watts into frequency is 50 divided by 60 whole square. Okay, so from this we'll get the answer as 625 watts here. So here is a 40, not 60. Okay, so 625 watts here. Next one. Identify the increasing order of voltage regulation of the following DC generators at the same load. Okay, so here under compound, shunt and differential compound generators are having the increasing order of voltage regulation. Okay, under compound, shunt and differential compound. So differential compound motor will have a maximum voltage regulation when compared to other two, right? Next one. If phi m is a peak value of the flux, then the magnitudes of the rotating magnetic field for two-phase supply and a three-phase supply are. In the two-phase supply is nothing but phi m, and the three-phase supply is 1.5 times that of the maximum flux respectively. So answer is A here. Next one, the phase difference between the any two successive third harmonic three-phase transformer is. So there is a in any cases the phase difference between the two successive third harmonic components. Let me be a V naught. Okay. So V1, V2, V naught. So this will have three harmonic components. The phase difference between them is 0 degrees here. Okay. Next one, at full load of transformer, the iron losses and copper losses are 3000 watts and 4000 watts respectively. The losses at maximum efficiencies, the losses, total losses is nothing but it is 2 times that of the iron losses. That is a 2 times into 3000 is going to be 6000 watts here. So B is the right answer. Next one, two three-phase transformers cannot be operated in parallel if they are so different. We can make them run as a parallel. Okay, when there are KVA difference. Okay, so you can parallel a 500 kVA transformer and 800 kVA transformer, we can run parallelly. Okay, even though we can parallel them if the impedance are different and the voltage ratios are different, phase sequence are different. So okay, so here the correct answer for this phase sequence are different here. Okay, voltage ratios are different also, we can manage. Okay, next one. So correct answer for this question is phase difference are phase sequence are different here. Okay, so let's move to the next question. A transformer operates 24 hours per day at full load. Its a full load efficiency is, so it is equal to all day efficiency. Okay, next one. If per phase rotor resistance and reactance of a three-phase slip ring induction motor at standstill are 0.02 ohms and 0.2 ohms respectively, then to obtain the maximum starting torque, the external resistance to be connected in each phase of the rotor is. So to get a maximum starting torque, the resistance R2 should be equal to X2 here. But here we need to add some extra resistance. So R2 plus RE is equal to X2. Okay. So what about the RE? RE is equal to X2 minus R2. X2 is nothing but 0.2. 0.2 minus 0.02 is nothing but 0.18. So answer is B here. The number of poles of 8 by 6 stepper motor can be, okay, the number of poles, okay, stepper motor is equal to, so it is nothing but the P, let me take stator poles plus PS by M here. So this is the formula here. Okay. Now what is the PS is nothing but here it is a 6. Okay. Let's assume it's a 3 phase. M is equal to 3. Now 6 plus or minus 6 by 3. Either it may be 4 or it may be 8. Okay. So among the choosing options, B will be the right answer here. Next one. The input and efficiency of a 3-phase 50 Hz 1350 RPM 4-pole induction motor is 9 kilowatts and 80% respectively. So efficiency they given, input is given. Calculate its stator losses. So it's a very common question here. Okay, yeah, the answer for this question I'm going to discuss here, it is 1 kilowatt here. So answer is 1 kilowatt. So I already discussed this question in my previous videos. If you want, just go through it. Next one, at a given load torque, okay, so the options are speed of single phase AC motor series motor is equal to speed of DC series motor, speed of single phase AC series motor greater than speed of DC series motor, power output of single phase AC series motor is greater than the power output of DC series motor, speed of AC series motor is less than that of speed of DC series motor. So at a given load torque, a single is a universal machine such as a DC series motor, it can be operated on both the AC as well as DC. But when you are operating on the AC, okay, so what will happen is the speed of AC series motor is lesser than that of, okay, speed of AC series motor is lesser than that of speed of DC series motor. So DC series motor will run very higher rate. Okay, next one, if two line currents of a three-phase system are 500 plus J 150 ohms 150 amps and minus 300 plus J 600 amps and the zero sequence component is 100 plus J 50 amps, then the line current in the other phase is, so the formula here it is, so it is I naught is equal to 1 by 3 into IA plus IB plus IC. So these are the two phase currents and zero sequence current is given. Okay. So from this value will be IA and this one will be IB and this one will be I naught. Substitute the values here and find the value of IC. We'll get as a 0.1 plus J 0.6 kilo amperes. So answer will be C here. Next 40th question here. In the operating region delta less than 90 degrees, so delta less than 70 degrees. So delta less than 70 degrees. The synchronizing power coefficient is where the delta is a load angle. Okay, larger in a round rotor machine than a silent pole machine. Same in the both silent pole and round machines. Larger in silent pole machine than the in a round rotor machine. And the last one 0 in both silent pole and round rotor machines. So answer here it is larger in silent pole machine than a round rotor machine. Okay, so there is a formula is there, so P will find the formula. Based on the formula also we can judge the answer as a larger in silent pole machine than a round rotor machine. Next one, 41 question. In a tuned power lines on load, okay, so tune, what is the meaning of this tuned power lines? So tuned power line means there is no voltage drop in the tune line and the sending end voltage receiving end voltage are same, sending end current receiving end current are same. That means there is nothing losses, so no losses. So as per that, all the above are the correct answers. Okay, there is no voltage drop, sending end voltage is equal to receiving end voltage, sending end current equal to receiving end current. Okay, that's nothing but tuned power lines. The tuned power lines are very impractical in nature. Next one, the 42nd question. The unit heat rate characteristics of thermal power unit shows. So it is heat input per kilowatt hour of output versus the megawatt output of unit. So answer is A here. Next one, the power factor of a dielectric depends upon. Okay, So it is depends upon, it's a function of temperature of dielectric only, and it depends upon on the voltage stress to which the dielectric is stressed. So both the options are correct, A, B and B. So answer is D here. Next one, the minimum clearance of 6.3 meters to ground is required for overhead lines when the operating voltages are lie between 110 to 165. So 110 kV to 165 kV lines require 6.3 meters of ground clearance. Next one, a synchronous generator is solidly grounded through a neutral reactance Xn. If the X1, X2 and X0 are positive, negative and zero sequence reactance respectively, and the LG fault current is more than three-phase fault current when? So when assuming that the X0 is less than the X1 at the same time X2 also. Okay. So this is our proper, this is the correct answer. If you want, you can use the formula IF is equal to 3V by X1 plus X2 plus X0 for a single phase, LG fault, and for three phase fault, it is V by X. Okay, and compare both the values, and you will get this conclusion that IF LG fault should be greater than IF three phase faults. And compare the equation, you will get the answer as C here. Okay. Generally in power system network, the load is represented as, okay, so generally in case of power system, it's a constant power in case of load flow study and a constant impedance in case of stability study. So answer will be B here. Okay. Next one, the respective B parameters ratio and C parameters ratio of a nominal pi and T model of a medium transmission line. So what is the first pi model? So in a pi model, what you will get is one. I will write about the B1. So B pi I will write. So B pi is nothing but Z, and B in case of T model, so is nothing but uh, y into 1 plus yz by 4. Okay. So similarly, C in pi model, it is, so here it is Z here. Okay, here it is Z, here it is Z. Okay, and C in pi model is uh, y into 1 plus yz by 4, and C in T model is y. Okay, so substitute this B pi by Bt is nothing but 1 by 1 plus yz by 4, you will get it. So simply 4 by 4 plus yz here. Okay, and similarly Ct also, so C pi by Ct is nothing but, so 4 plus yz by 4. So answer will be D here. So D is the right answer for this question. Next, for selecting the circuit breaker, dash should be determined. Okay. So for selecting circuit breaker, the initial current that flows on the occurrence of the short circuit current only, and transition current that flows at the time of the circuit interruption only. So both are the A and B here. Okay. Next one. A 60 Hz 4-pole turbo generator rated 1000 MVA 11 kV has an inertia constant of 8 megajoules per MVA. The mechanical input is suddenly raised from 80 megawatts for an electrical load of 60 megawatts. Okay, then the rotor acceleration is, neglect the mechanical and electrical losses, then the accelerating power Pa is equal to, so by Gh by pi into F into d square delta by dt square. So accelerating power means, what is accelerating power? It's a difference between these two. So I'll write here 20 is equal to G value is 100 MVA into H value is 8 divided by pi value is nothing but 180, frequency 60 into this acceleration A here, right? Or d square delta by, write it down, d square delta by dt square I can write, or I can write as a acceleration A. So substitute this value, will get the answer as a 270 electrical degree per second square. So answer is A. Next one, the ratio of full load volt amperes to the short circuit volt amperes is equal to, it is nothing but Z per unit. Next one, the 51st question, choose a wrong statement among the following. The impedance relay is less affected from the synchronizing power surges as compared to reactance relay. The impedance relay is less affected from the arc resistance as compared with the Moore relay. These are the correct statements only. The impedance relay is more affected from the synchronizing power surges as compared to reactance relay. So this is a wrong statement. The impedance relay is used for protecting the medium transmission lines. Correct statement. So among them, the C will be the wrong option here. The impedance relay is not affected from the synchronizing power surges as compared to reactance relay. Okay. Next one, 52nd question here. In case of cover voltage protection scheme, what are going to use user? So using of ground wire is a shield method, whereas use of spark caps and lighting arresters are a non-shielding method. So answer A is the right. So among the other are the wrong options here. Next one. So IDMT relays. So IDMT relay are used to protect the transformer against external short circuit. Inverse definite minimum time relay are there. Next one. Resistance grounding is normally used for, it is used for low voltage short head transmission line. Okay, short overhead transmission lines will be there. Next one, the diagonal elements of a nodal impedance matrix are strengthened by adding shunt inductances. Answer is shunt inductance here. Okay, calculate the collector current of a BJT, silicon BJT, when the DC current gain, base current and reverse saturation current of collector to base junction are 100 to 20 microamperes and 500 nanoamperes respectively. Okay, so find the value of IC. IC is nothing but the formula here. So beta into IB plus 1 plus beta into ICBO. We know that beta value is what? This value is the beta value and IB value is 20 microamperes and this will be ICBO 500 nanoamperes. Substitute this values in this equation and we'll get the answer as 2.051 milliamperes. Okay, so which of the following gates can be used to realize all the possible combinations of logic gates? Logic gates here. So it is not a NOT, it's a NOR gate. Okay, and OR gate, NOR gate, XOR gate, NAND gate and AND gate. So what are the universal gates that you know? There is nothing but NAND and NOR gates. So we can, using this NAND and NOR gates, we can realize the remaining other gates. So answer is NAND and NOR. Okay, next one, the AC bypassing of RF by CF in a common emitter configuration. So it is to increase the AC signal across the emitter base junction. So when we are coupling this RF and CF, it is going to reduce the noise levels and increase the AC signal across the emitter base junction there. Next one, a current controlled voltage source is equivalent to. So the options are series voltage feedback amplifier, shunt current feedback amplifier, shunt voltage feedback amplifier and series current feedback amplifier. The correct answer is shunt voltage feedback amplifiers. Okay, an unstable multivibrator has a dash. So in an unstable multivibrator, it will have two quasi-stable states. It will have two quasi-stable states and zero stable states. Okay, so quasi-stable states. Two quasi means it's going to oscillate between the two stable states here. That is not going to remain same. Now next, choose an incorrect statement from the following regarding the pin numbers of 8085 microprocessor. So here I see there are 40 pins in the 8085 microprocessor. You have to remember that 40 pins also. So serial input output ports, that is SIO and SOD, are 5 and 4 respectively. Is correct. Reset out and clock out are 3 and 37 respectively. It's right. Ground and VCC are 20 and 40 pins are respectively. It's right. And this is a wrong statement. So RST 6.5 is at 8 and RST is nothing but 7. Okay, so RST 6.5 and R 7.5 are 7 and 8 are respectively. So wrong. Okay, next one. Okay, next question here. A separately excited DC motor operating in the first quadrant is fed from three-phase semi-converter. If the freewheeling diode is open circuited, then the motor is going to be operated. It can be operated in the first and second quadrants. So this can be operated in the first and second quadrants here. Okay, answer is B here. Next one, speed of three-phase 2-pole 60 Hz synchronous motor is controlled by a step-down three-phase cycloconverter. The maximum speed of the motor can be. So generally, when you're using a say three-phase cycloconverter, the speed is reduced to around 35%, around 35%. Now, what is the NS? NS is nothing but 120 F by P. So simply we'll get it as a 3600 RPM. And when you're using the cycloconverter, the 3600 into 35 divided by 100 will be the actual speed. So it is around 1200 RPM here. Okay, next one. If the time period of the output of a single phase bridge rectifier is 25 by 3 milliseconds, then the supply frequency is, okay, so Fs is equal to 1 by 2 into T, that is equal to 1 by 2 into 25 by 3 into 10 power minus 3. We'll get as a 60 Hz. Answer will be D here. Next one. The input current of a three-phase AC voltage controller is found to be sinusoidal. Okay. Then the type of load and the firing angle is. Okay. So here the two options matches with the answer. Either it is capacitive and zero firing angle, or okay. So D resistive or 2 pi. So these two are the correct. So for this question, A or D both are correct answers. Next one. Basically brushless DC motor is a dash and its torque speed characteristics are similar to dash. So nowadays you are using the BLDC motors, brushless DC motors. These DC motors are nothing but they are nothing but a synchronous motors. Okay, synchronous motors, and they have a similar characteristic to DC motors. So answer is it's a synchronous motor and is equivalent to DC motor here. Next one, to get a maximum. So in the question itself, it's a typing mistake. To get a minimum here. To get the minimum harmonic distortion in the three-phase in the output, three-phase cycloconverter requires 36 SCRs. So answer is 36 here. Next one, in a constant flux control of a three-phase synchronous motor at medium and rated frequencies, the supply voltage V and the supply frequency F are related as V is equal to K into F, where K is a constant, but very low frequencies the supply voltage should be equal to greater than K into F. Next one, if active input power of a single phase semi-converter with the RL load is 200 watts and the firing angle of pi by 3, neglecting the harmonic component of the output current, calculate the reactive power input. So reactive power input is nothing but total power divided by cos angle is 60 pi by 3 into sin 60. It's nothing but 200 divided by root 3 will be the answer. So B is the right answer. Okay, next one, the 70th question. A three-phase voltage source inverter operates in 180 degrees conduction mode with a star connected resistive load. If the input DC voltage is 200 volts, then the peak to peak value output voltage. So peak to peak value will be 2 times that of the supply voltage. So peak to peak value. So that means the peak to peak voltage will be what? 2 into 100. So 200 volts. Answer will be B here. Next one, 71st question here. The input voltage of a single phase full wave AC voltage controller is 282.8 sin 314T. If the load is resistive and output voltage is 162 volts, then the input power factor. So input power factor will be equal to V0 by Vi. So V0 is nothing but 162 divided by Vi is nothing but 282.8 divided by root 2 is nothing but 0.81. So answer will be C here. And next one, in a quadrilateral speed time curve of electric traction system, the accelerating during the successive time periods are. So in a quadrilateral system here, it is like this. Okay, quadrilateral system here, the speed time characteristics curve of electrical traction system accelerating during successive time periods are. So it is a positive and 0 and negative. So answer will be B here. Next one, in arc furnaces, maximum power input occurs at when the practical power factor of the primary is. It is in the range of 0.75 to 0.80. Next one, identify the correct combination of respective electric arc welding and electric resistance welding methods. So they are nothing but hydrogen shielding and projection welding. Next one, if a plane angle subtended at a point is pi by 3 radians, then the solid angle subtended at the same point will be. So solid angle subtended will be W is equal to 2 pi into 1 minus cos pi by 3 by 2. So we'll get it as a pi of 2 minus cos pi by 3. So answer will be this one here. Next one. Choose the correct order of electric discharge lamps in their increasing order of the efficiencies. Okay, so I'll write the for neon lamp the efficiency will be 10 to 30 lumens per watt, and for the mercury vapor lamp it is going to be 35 to 65 lumens per watt, and for sodium vapor lamps it's going to be 50 to 150. So here it's for 10 to 30 here, and 35 to 65, and from 50 to 150. So answer will be C here. Next question, to get a maximum illumination at a fixed horizontal distance L of 10 meters, what vertical height of the lamp should be indicated? So here H is nothing but L by root 2, which is equal to 10 divided by root 2, nothing but 7.07 meters. Answer will be A here. Next, theft electricity is dealt in dash Indian electricity rules. So it is in section 135 here. Okay. And the next question, if D is the diameter of circular area A swept by rotor and V is the wind speed, the wind power is proportional to, it is proportional to D square into V cube. What is the D is for diameter, V is the wind speed here. Okay, so C will be the right answer. Next one, so similar kind of question asked in a previous TS paper itself, right? Next one, last question of this video session, a solar pond is a combination of, so solar pond is a combination of solar energy collection and heat storage, solar energy collection and energy storage. So these two are the correct options for this. It's a combination of B and C. Okay, that's it friends. So we'll stop this video here and we'll continue the next papers of TN NPTs here. So if you like this video, please subscribe and share this content with your friends, and all the best for your preparation. Thank you friends. Have a nice day.